Hello, and thanks for joining us today for how to manage regulatory policies. Excuse me. With knowledge graphs to mitigate compliance risks. Today's presenters are Ralph Hodgson, CTO, TopQuadrant, and Norm Friend, Semantic Solution Engineer, also TopQuadrant. You've been placed on mute entry for this webinar, but you can still ask questions, which we'll get to at the end. Just look for the questions module in your GoToWebinar interface, and you can enter them in there. If we can respond during the webinar, we will, but otherwise we'll get to it at the end of the presentation. With that, I'll turn it over to Norm to start.
Thanks, Ian, and thanks for everyone for attending today's masterclass. We're going to cover, as mentioned, the topic of managing regulatory policies with knowledge graphs to mitigate compliance risks. A quick overview of what we're going to discuss today. First, we'll go over the concept of risk and risk indicator models and what they are and the different elements related to a risk model. Then we're going to get into some examples of risk models and how they can be governed within a knowledge graph. And along with these examples, we will provide some demonstrations around these models within TopRate Edge, the platform from TopQuadrant. And then we'll finish up with some closing remarks, recaps, and any questions that people may have. So why do we need to talk about risk today? Risk management is not only about minimizing the negative impacts, but also identifying opportunities for growth and innovation. A proactive risk management approach allows companies to make informed decisions, adapt to changing marketing conditions, and create a sustainable and resilient business model. It helps protect these valuable assets within our organization from potential threats such as market vulnerability, natural disasters, cybersecurity breaches, fraud, and operational failures. It allows companies to anticipate potential disruptions and develop contingency plans for that business continuity. And finally, it helps companies identify and address compliance risks, ensuring that they're adherent to relevant laws, industry standards, and ethical guidelines. What you're seeing here is the process by which we have taken information both from bankpolicies.com, from IBM, and from Oracle, and we're pulling that information into TopRate Edge in the TopRate Edge, along with, as you see on the top, things like the European Banking Authority, EBA, or FFIEC, or any of the other regulatory bodies out there. And we're pulling that information in, applying an ontological layer over top of that, and allowing us, using a virtual graph mediator, to pull the data, the actual instance data, to build this risk management governance model. And so before I go too deep, I want to talk a little bit about the different types of elements, and then I'm going to have Ralph demonstrate what exactly are we doing within TopRate Edge. So as you can see, there's multiple assets that are related to risk governance. If we start at the top, the enterprise assets, there's approximately 720 information assets, around 210 forms, form items, reports, policies, business activities, business processes. So when we start looking at the governance of risk overall, there's a number of different types of assets at the enterprise level. When we look at the technical assets, there's about 50 different business applications that house information related to risk. There's a bunch of executables that we will run that actually calculate risks. Then we can get into data assets. So what specific quantities, databases, database tables, and columns are used for risk? How do those tie to business terms or industry terms? And then finally, right down to the different data types that we're using. So at a high level, when you look at the different types of assets related to risk, we're going to demonstrate all of this today. So with this, I'm actually going to pass this over to Ralph to do a quick overview of what we want to show today.
Thank you, Norm. I just want to confirm that I'm sharing my screen. Yeah.
Yes, we can see it.
Okay, great. So the first thing to say is, what are you looking at here? This is top rate edge, and it's a particular set of configuration of pane things that you're looking at here. And the way I'm going to be working with this is sometimes I will be in forms, which is what you see here, a form. Sometimes I'll be in a hierarchy view, which is a way of looking across the graph. Sometimes I'll be clicking too much because I'm kind of very familiar with this environment. What I won't be doing in the demo is showing all the different kinds of panels we could have, because this environment, top rate edge, is highly configurable, and you can have different layouts, and including the ability to use sparkle and that kind of thing. As I travel through this, some of these connections that you will see me doing are directly expressed as statements in the knowledge graph, but others are inferred. So one of the strong features of our approach here is to use Shackle, which is not only a constraint language for describing data in verifying it, but it's also a way of computing values. So there, behind some of the clicks that I do, there will be inferences that generate interesting information over the knowledge graph. So with that said, let me explain what you're seeing here. I happen to be on TQ Bank Personal Data Protection Analysis, which is an analytics model. TQ Bank is top quadrant. I've been building, pretending to be a bank, and it's been a great educating experience to figure out what a bank has to deal with. It's an enormous amount of regulations, and I have good insight into all of that now. So what you're seeing here is a hierarchical view where the arrow means outgoing or incoming. So these are all outgoing right now. And if I click on this guy, you can see that this is analyzing a personal identifiable information risk. And when I click on that, there is a way to go to a broader risk to see what it's indicated by. It's by a business activity. It's pertinent to a policy, by a data compliance policy. And I will just look at the risks here first. Again, what you see here is computed. There are connections to all of these data protection things, including things I will click on in a second. I'm here for PI ratio. The important thing to mention here is that the color of this, the green, red, these are computed on the fly from the values associated with these indicators. And to illustrate that, I will go to one of them. I choose the right to be forgotten. And the right to be forgotten, I'm now going to go to the form. You can see that it's described here with identifiers. I'll close that. It has risk attributes. It's this kind of risk. It's an indicator for the same. It has a formula, A divided by B, where A is unresolved erasure cases and B is the total number of erasure requests. And each of those are bound to a variable. So this is the A variable, and this is the B variable. And there's a min value, max value, because it's a ratio, it'll always be maxing out at 1. We are computing the tolerance of risk here when we describe the low risk value as 0.2, and the high risk value being 0.6, and the moderate risk at 0.4. So this has got a low value. And later in the demos, I will go to the regulation. This is actually connected to an RDF graph of GDPR itself. So this is GDPR obligation coming from Article 17, paragraph 1D. And as I say, I'll demonstrate that later on. The other interesting thing to show is who owns this. And here we see that it's the Chief Data Protection Controller, and that's his job title. And he's busy with his policy, and he's the compliance owner he or she is the compliance owner for all of that. Interesting. So if I'm logged in, I can see that I've got one high here, two, because one has just changed and this update hasn't happened yet. And the medium is 8. They're all the medium, and there's one. Sorry, I got that the wrong way around. Low is 2. We just put it high, medium, low. So we're seeing an overall score which is 46%. So that's an interesting view that you can see that there's immediate value here for someone in a particular role to see where they have to get busy, and that's a place to end on the PII front. I would like to show you another example of this. So I'll go to another risk, which is an EBA risk called, which one do I want to take now? The small, medium, and enterprise risk. So this is a risk to do with how the banks have to deal with small, medium, and enterprises. We used OpenAI to generate this by giving it a prompt that was based on the ontology, and it came back with a very useful set of statements. This quote I added myself, reading something on this document, I think. Yeah. So again, this is a interesting thing to show. I think where I show well, what are the values for this guy? Well, there are 7 things in the high, 2 things in a medium, and then 5 in a low, and you get an overall score of 52%. So we better look after that guy. And if I were to go to SME 11, for example, we might see some of the reasons for this. And again, we might want to know where is this variable coming from, and we can see it's held in a database column, and that database column is what we're looking at here. It's holding the value for the exposure weighted average, yeah, LGD. So with that, I think I should pass back to you, Norm. In the interest of time, it's so a lot of time working the side of the demo. So back to you. Yeah.
Thanks, Ralph. So let's walk through some of the stuff that Ralph just shown in terms of the concept of risk and risk indicator models. Obviously, there's different types of risks within an organization, but in general, it is an action or a situation that companies wish to avoid as they have undesirable outcomes. These share similar characteristics in terms of scope, frequency, and permanence. They also have causality and contextuality. And so each one of these concepts of a risk are indicated by one or a series of risk indicators, which could be applied, as Ralph mentioned, to multiple different types of risks within your organization. So permanence, scope, and frequency, some which we alluded to in the previous example, is defined by scope. How many people are actually impacted by said risk? Is it within our organization? Is it within our industry? Or is it something that's global? How often? What's the frequency of these risks that we see within our organization? So an example, for example, the last global banking crisis was in 2007. And then the permanence, how long does this actually last before it goes to a state of normalcy? Some of what we're going to dive deeper into is this concept of the risk indicator model. So as mentioned, there's a number of different elements in play here. First of all, we have this concept of a business activity, and that business activity that we do is mitigating some sort of risk. That business activity is also related to a compliance for a policy that we have within our organization. And as mentioned, that business activity has some sort of compliance owner through a job title. The risk at the center, at its core, might be a part of an enterprise risk, but it's always indicated by, and you'll see the stars in the diagram here, multiple risk indicators. A risk indicator is going to have a value. As already demonstrated by Ralph, it's going to have a minimum value, a maximum value, a moderate value, and an actual value as to what is the value of that actual risk. And those are measured through what we call quantity variables. So a quantity variable is a mathematical calculation. As demonstrated, it might have 3, 4, 10 different elements that are measured, but that defines the actual risk value for that particular risk indicator. When you start exploring the entire knowledge graph, because really that's what we're looking at is a knowledge graph, the entire knowledge graph applies to regulatory compliance. Each one of those regulations may have a chapter, they may have a paragraph, and each paragraph will have what they call a regulatory norm, and that regulatory norm is what we apply to that risk indicator. So lots of different pieces at play here when it comes to defining risk and how we actually connect all of the pieces right from the policy to the risk indicator to how it's expressed, right down to the data element and the software that actually manages that information, and right down to the risk, the industry terms. So what we want to do today is walk through step by step the different elements within that model. And the use case we're going to look at today is within TQ Bank and the financial regulatory bodies that create these risk models that you're seeing today. So at a high level, the architecture that we're looking at today is looking at TQ Bank as an example and the enterprise risks that apply to bankings today. Then what we did was we looked at EBA, so the European Banking Authority, as risk indicators. We tie that to the databases that hold that information. And then what we do is we apply that ontological layer over top of it to define what does the model actually mean and what does it look like. So number one, what are the risks within a bank? So what I'm showing today is the process by which we took information from the largest US banks and their SEC 10K filings. We extracted the information, and this is where we start using things like LLMs. And we prompt the LLM to actually extract what are the risks within our organization specific to banking, extract those phrases, and then build a risk knowledge graph, which is what Ralph was showing and will continue to show. So what we did is we took this information and at the end of the day ended up with about 1,061 risks that we extracted out of these SEC filings and brought into the knowledge graph to define the risks. What about risk indicators? So again, we'll take the information, in this case from EBA, extract that information. They actually provide it in a CSV format where we can then convert that information into RDF. So we have it in a knowledge graph. And then we bring that into top-rate edge, applying both the FinRep ontology, the EBA ontology that we just finished importing, as well as any of the other edge ontologies that define what does it mean to be a risk indicator. Then we actually look at things like, can we leverage OpenAI for content elaboration? So as Ralph mentioned earlier, there are a whole bunch of paragraphs that we've extracted using LLMs to define what that means to be a risk indicator. That gets plugged back into the knowledge graph and tied to those risk indicators. And then finally, the concept of those quantity variables. So when we bring in all of those risk indicators, we also then can pre-calculate and create formulas to define how do we define the actual the quantity or the amount of risk for each one of those different risk indicators. What we discovered is through this exercise, there was about 76,000 different quantity variables and calculations that we would use, and those would be spread over 803 different risk indicators. So you can start seeing the size and scope of what it means to actually identify risk. So with that, I'm going to pass it back over to Ralph, and then we're going to go into a deeper dive of what it means to be a risk indicator and quantity variables and how they map to all of those different types of elements like the policy, right down to the data element that stores the data that we can actually calculate the quantity variable. And so with that, I will pass it back over to Ralph.
Thanks, Noel. And again, to confirm, I'm showing my screen, yeah?
Yep.
Okay, so the screen I'm on now is actually a screen showing the EBA risk categories of asset quality all the way down to solvency risk. There's the SME risk category that I was showing earlier. And I'm going to be, in this demo, looking at one or two of these. I've got here a link to the document that was the basis of discovering what all this meant, the EBA methodological guide. So why don't I just start with solvency, perhaps, yeah? Solvency at the bottom here. Again, this is generated by OpenAPI. What does it mean to have solvency risk? And it's interesting to be able to pull that content rather than figure it out from all the books that I've been studying. Yeah. So this has got so many risks. You can see them all here, and they're ordered in not a particular way there. But if I want to look at them in terms of their values, the solvency risk is showing a 50% score overall, 21 in low state, 15 in medium, and 26 in high. Yeah? So why don't we look at 15? That would be a good one, perhaps. 15 is showing that it's an indicator of the solvency risk kind. It's an A over B. It's concerned with tier 1 capital, and it's concerned with transitional adjustments. So this is variable A, this is variable B. So when we have an external system querying edge, it will be a query that delivers the formula that has to be used, and it will also be a query which will have a response to where to find these things. And here we see it's in database column with which I'll click on now. The value is held here. So the quantity variable is is not a physical data element. It's a quantity that has to be connected to a physical data entity. It may be something in the data lake. It may be living as a JSON data element somewhere. But here what we have is a recognition of it in a database column. And it's an Oracle varchar, and it maps to a term. This is the mapping to terms. You see that it mapping to common equity tier 1. And the idea of a business term is to define a specification for how the value should be. How many, if it were a string, what's the length of it? If it's a string like a social security number, it would describe the structure of it. Here we are dealing with strings that are carrying values, perhaps. Well, certainly carrying values in this case, but it's a common specification for a number of things, as you see here. Yep. And the description of what that means came from Investopedia. Yep. So we could go back and look at the other thing that's going on with this quantity variable. It was derived from this. This is where we traveled from, and we can go back to that this way or by clicking on that link. Yeah. The other thing that we might want to do here is look at some more of what's going on with this solvency risk. Yeah. And so let me go back to solvency risk this way, and pick up the story on the solvency risks. I click on this guy, and there I'm back on it. Incidentally, in this view, you can also get we have nested forms, so we can get to see things over here without having them over here. Yeah? So it's busy with this risk, as we saw, and there are so many indicators here. Yeah. And what about the policy? Well, there is a policy for it, and there is what we call an assurance enabler. In the enterprise context, we get a view of who's looking after this, and this is a business activity which aims to assure compliance with three policies here. It's a sub-activity of IBM business activities that are supported in the IBM data warehouse. And another thing we can show are the processes that this activity relies on. So we have a list of processes here that I could dive into, but you just by reading them, you got to. This is not a process model behind here. It's just simply a process catalog, and who owns it and why is it there, and how does it connect to other things like the risk policies. And so the enterprise context is a way of getting that lens, that view into how this activity is important. The other thing we can do here is apply RACI constructs, what are called RACI, responsible, accountable, and consulted, informed. And so this is performed by a risk analyst. The informed party is this. The accountable party is the EBA solvency risk VP, and this VP is the compliance owner for a lot of stuff. So he or she might want to divvy this work up to have support on this. So that's the enterprise model aspect of what we're doing here. And it's the real benefit of being in knowledge graphs. Not only do we have the expression at the technical level, we have it at the enterprise level, and we can use that to notify people when the risks are in a bad state. So when said, notification can happen to the right person. Yeah, and this is what it means to do risk management governance, and it's something that I think the market is really needing to have these days. Is there time to go somewhere else? Maybe I can go into SMEs, because we are one. So it's kind of interesting to TopQuadrant is one. So it's interesting to get a feeling for this. Again, the description is there. So we have again the indication of the status, and you see a much simpler. There aren't as many things going on for the SMEs, but this is changing actually, because the vulnerability of banks to what happens with small, medium-sized enterprises is something to to kind of take account of. Yeah, for example, if I would want it with more time here, I could show you our search capabilities. I'll do a little bit of take on this, but if I look for liquidity, well, LCR would be a good one. The LCR is a liquidity coverage ratio, which is a very strong concept in banking. And here we get a view of where this occurs, how many risks are associated with liquidity coverage ratio. And that's another good view into the knowledge graphs. Yeah. So perhaps I hand back because we have 2 more places to go and quite a few more slides to show, I think. So back to you, Noel. Yeah.
Perfect. Thank you, Ralph. So as Ralph demonstrated, there's multiple different elements related to a risk. The risk indicators, we talked about the quantity variables and how they're actually tied right down to a data element in some application that's actually managing that data. So the next step. So we talked about EBA, we talked about bringing in information from EBA, we talked about how we can import things like and leveraging things like LLMs to actually describe what those things are. Let's talk about the Federal Reserve Board. So the Federal Reserve Board, and now we're going to talk about things like forms, reports, schedules, and MDRM items. So similar concept, except different data that we're pulling in. In this case, we took information from the FRB and the FFIEC. The FFIEC has a number of forms that are sitting out there on the web. And so what we did was we converted them to a knowledge graph as well using and put them into an RDF format. Once they're in an RDF format, we can then bring them in and apply the same ontologies that we've been talking about on the edge side, but now we also have the Federal Reserve Board ontologies. What we garnered out of this, when we look at the FRB forms and schedules within a knowledge graph, when we look at the MDRM data, we had 27 schedules associated with 209 forms, and each one of those forms have a number of different MDRM items associated with it. In fact, a little over 75,500 MDRM items. So different banking authority, same concept. In this case, we're looking at the actual forms and the schedules related to the Federal Reserve Board. So in this particular case, we're going to look at the FRB 2052A Complex Institution Liquidity Monitoring Report. So this is a specific report that we have. And again, because we're using a knowledge graph, we can create these connections between a risk indicator, the quantity variable that we keep talking about, where the value is being held in terms of the data element, the business term that it's related to. And this is super important because a business term can be related to multiple data elements. It also could have industry terms that it's related to. And then we have the concept of a form and a schedule. And so the relationships that we're all creating in this particular case for the FR 2052A, they're all related to that risk indicator, which again is related to the actual risk. And so at this point, I'm going to pass it over to Ralph again to show a brief demonstration of how we're actually connecting these particular types of items.
Very good. And I'm sharing my screen again. So this is the FRB FR 2052A, and I have it showing in some detail on the form here. It's analyzing a number of risk kinds, yeah, and it's producing a report. And that's, in fact, using an external piece of software for that to happen. We'll explain some of that later. The important thing is to go and check how this is held in a in our model. Yeah, so we want to go to a particular part of this, and I want to perhaps switch to forms view. But maybe I think I can do that quickly enough from here. So what you'll see me doing is going to forms, and so I have a way to get that. I've actually configured this so it can't be done, so we block that from happening. But let's see if I can get to the forms some other way. It's indicated by this liquidity coverage ratio. Yeah, no, I can't do it that way. So what I'm going to do is go and find it another way. So we go to a collection, and we go to, there's so many different kinds of collections here. I configured my analytics models before this webinar, but it's blocked me from going into a particular form. So I want to go there this way. So we go to the forms here. Well, let's use the MDRM items themselves, and then I can go to a form this way. So I want to go to a form. We could just type form here, and we're on. Actually, I go specifically to the FRB forms. So we type form again here. We get to FRB form, and that way I can navigate to the one we want to see, which is actually it's FY. There it is. Yeah. So sorry for that little bit of fumbling around there. It's just that I had configured my other screen to block access to certain things. So here we see the form and its description, and where we got that from, and where the descriptions for how to do this are. The example is here, so everything is connected to FRB, and I need to just go here to get back to where I was, and click on here again. So what are the items that this thing is busy with? Well, we have a backward inference going on here to these items, and there are 2,890 form items that make up this form. And if we go to this guy, we can see, let's just take the first one perhaps, click on this guy, and we are looking at something that is described as reference link, and it belongs to the series, and it's used on this form. But there is what's called a usage contingency, which is a little bit of complication that the FRB has got here. So the fact that it's on this form is conditional, and this is called an information bearing property in the technical world. If we just look at the details of this, you can see that it's got four properties on it. What is its effective start date, effective end date? Is it confidential or not? What kind of reporting type is it? And that has an enumerated set of values. So this is interesting because the same MDRM item it can appear on the same form, but with different stipulations of effectivity, and that's captured in the model using what in the database world was called information bearing properties. In the knowledge graph world, it's called reification. Yeah. So back to where I came from, there are, as I say, so many items here, and we have so many forms, and I could just give you a sense of that by taking that away and getting to all the forms. One other form, which is something I'm very familiar with from work a few years ago, was the FRY forms. I just got to get the right FY. Sorry, sometimes I say FY, FR, and I should say FY, but I'm looking for a particular form, which is the 9C. Yes, the 9C form. Oh, it's not showing up. I don't know why. But there's 209 of these things, I'm just not typing FR properly yet. So, okay. So we have FR. Yeah, there she is. Yeah, I wasn't typing properly there. Sorry for that. So FR9C is another kind of thing which has schedules. And if we click on the schedule, we can see its details. And going back to the form itself, we can see that it's linked as well to the FRB. Yeah. So with that, yeah, it's okay for me. Yeah, there's FRY9C fully described there. Yeah. So with that, I think I'll hand back again because I see that we're running out of time a little bit, with one more thing to say, I think, or 2 or 3 more things to say. So back to you, Norm. Yeah.
Thanks, Ralph. So as mentioned, now we're starting to look at tying risk and the risk indicators to the actual regulations and to the actual forms themselves as demonstrated. So now let's take a look at the whole concept of risk management governance. We've shown a lot today. We've shown a lot of elements that are related to the concept of a risk, how we can calculate those risks with quantity variables assigned to risk indicators. How are we doing the entire thing? Most of this data, as Ralph alluded to, is not even stored in Edge. That's not what we do. Our job is to manage the models themselves. And so if you look at the classic concept of risk management and the governance of risk management, on the right-hand side, you'll see all of the different areas and applications that are actually storing this data. This information is not being stored here. It's being stored in things like Oracle, in Tableau. And so what we look to do is create this concept of a virtual graph mediator. And this is the connection that's talking between TopRate Edge and the risk management governance model that we just showed, and those applications to actually define it. So let's walk through this. So the first thing we want to do is configure this virtual graph management mediator, VGM, with specific risks that we're interested in. That then goes in requests information and those equations and the details from TopRate Edge to understand what that particular risk is, to define what that risk is, and as shown, even the descriptions of what those risks are, and optionally things like the quantity variables. And so there's a communication that's now happening between the VGM and TopRate Edge. And then what happens next is the return of risk evaluations. So the VGM will then say, all right, we have this equation, A divided by B, A plus B divided by C. Those are equations that are coming from different places within our database architecture that we need to create some calculation. And so what happens is, and this is what Ralph was showing in terms of the numbering of high, medium, low, is we're actually pulling the data from those particular applications and we return that evaluation. As mentioned, those quantity values live in many different databases, data lakes, applications, etc. Finally, what happens is that risk management can happen on the left-hand side, because now what we've done is we said, here's the concept of a risk, here's what indicates a risk, here's how we calculate said risk, and now what I want is those people, as mentioned in the organization, that are responsible for managing said risk, can actually look at the status of those. And so this is what we want to, again, end with in terms of the ability to combine all of this stuff into a single application that allows us to make some of those decisions. And with this, I'm going to pass it once back over to Ralph. Or Ralph, do you want to just jump right into the next area where we go into GDPR?
Yeah, I can do a very quick thing here. Not on GDPR, but I should do a little quick thing on just something I wanted to show earlier, but felt I didn't have time for.
Yep,
but
I'll pass it over to you then.
with a minute I can do this. But I'm going to indicate how complex these quantity variables and risk indicators can get. So this is funding plans risk analysis, and it's over here, and it's at a 5 right now, and we can get to see how busy this is with respect to all these guys. One of the, and this is for any technical people that are on the call, but really, and because I felt that there might be a technical audience here that would enjoy seeing a little bit of Sparkle. So I'm going to run a Sparkle query here, which says, I want to know for this particular funding risk, which is the subject, that there we're going across the graph, is what's it indicated by, what are the variable bindings? I want to count the number of quantity variables. I have to group by RI, and then I order by descending. Just to get you a feeling for that, there are 20. This is the busiest one, FTP3. So that's the way I discovered the busiest, and you can see how busy that is. Yeah, loans and advances to households is variable A. The last thing here is something about general governments, variable T, and there are all the quantity, 20 of them are here, yeah. Held for trading, variable name K. So a bank has to deal with these distinctions between households, financial, non-financial, governments, general governments, all kinds of stipulations here on what has to be reported. So that was my quick kind of view of things for the technical audience. Yeah, I thought feature something for that. These Sparkle queries can get very elaborate, but I chose a simple one here. Yeah. Back to you, Norm.
Perfect, thank you. So finally, what we wanted to look at is, again, how do we tie this back to regulatory bodies? And so the example we're going to demonstrate in this last piece is GDPR. So we were able to take GDPR and the GDPR documents. We transform them again back into RDF, bringing it into a graph. Aligning that with things like RICO ontologies. So again, you'll notice that there's multiple models, and this is the complexity that we're dealing with in the financial industry. There's multiple ontologies and models that are behind the scenes, and the out-of-the-box edge ontologies that come pre-baked. What did we discover when we created the GDPR knowledge graph? Well, we found that there are about 1,300 GDPR parts. There's 11 chapters within it, 15 sections, 1,200 approximately paragraphs, and about 100 different articles. And so we take this information and again apply it as part of a knowledge graph as another overlay over everything that we've just finished talking about. And so again, in this the last demonstration that Ralph's going to go through is show how we can actually bring in the regulatory compliance that's assigned to a risk, that has a chapter, that has a paragraph, that has this concept of a regulatory norm, and that risk indicator has this applicable norm that's applied to it. And again, we're reinforcing the concept of the quantity variable, where the data element actually comes from, and any business term that's related to it as well. So with that, I'm going to pass it over to Ralph for the last demonstration, really around how, in this particular example, GDPR can be used as an overlay to the concept of risk.
Thanks, Norm. We have to go a little fast on this. So there I am on FTP3, but we really want to be in the PI world. So here I am looking at PII again, and we want to go and look at a particular indicator. What about the encryption indicator, perhaps? That would be an obligation. So here we are on an encryption indicator, which is a risk value of medium right now. The applicable regulation norm that we're connecting to here is this one. and it's stipulated by these paragraphs. It's the regulated party is the data protection officer, the beneficiary is the data subject, the outcome is protection of right outcome, and it's of an obligation kind, the right to be forgotten. So let's look at the regulation. What is it saying in this paragraph? Well, that's a subparagraph of this paragraph. Here we are looking at 4 paragraphs of Article 18, where the obligations were detected. Again, this is work that OpenAI could help with, where you're looking for particular phrases like shall, should, could, may. Those kind of words can help you understand what are obligations, what are prohibitions, and what are permissions. And as I descend here, as I ascend up here, you get to see the article, and you can see within which section it is and which chapter, and eventually I get back to the whole document. Yeah, so we don't need to go all the way up there, but we could. Yeah, I've chosen to. So what we have here is all of GDPR. Yeah, and we have CCPA, the California Protection Act, in a similar way. It was a bit harder to do CCPA, able to write parsers, again, addressing the technical audience, to take the content of GDPR and organize it in an RDF graph using the RICO, the Regulated Compliance Ontology. So that's the quick demo of GDPR. I don't think I have time to do everything you promised, Norm, because we need some time for questions. Yeah. So
Yeah.
okay.
Thanks, Ralph.
Yeah.
So I'm going to close, and then we have a couple minutes left for questions. But again, just as a recap, obviously there's different types of risks, and I think we've demonstrated how we can manage and govern those risks within TopRate Edge. We've talked about how risk indicators can be modeled and create relationships to those risks, and then create bindings, quantity variables and bindings to the actual values within the actual data that would define and create values for each one of those different indicators. And I think then we've shown how we can take all of those assets, can be tied with all of the other enterprise assets, the policies, the governance, the business terms, the technical assets, right down to the actual database column that stores that information, and creating those relationships within a knowledge graph. I'm not going to go too much into this one because, again, I want to take some time for some of the questions that I've seen. But what we find is often people are sitting at level 1 and 2 when they're trying to figure out what is the impact of uncertainty within my organization when it comes to risk. And I think what we're trying to demonstrate here, there's a great document by the MIT Sloan Management called Risk Intelligence and Resilient Company, and the Resilient Company is the name of the actual paper, where they focus on level 4, which is exactly what we've shown, is how can we actually create a risk impact network and then move to level 1 from an impact uncertainty perspective. So with that, I'm going to stop. We have 5 minutes for some questions. I see there was one, just wondering if the slides will be shared later or not. Ian, I'm sure we can share the slides afterwards, as well as the recording is going to be available.
Absolutely.
Next question, what is the best approach for converting CSV to RDF using RDF model or R2ML? There's another question around in terms of how we actually can make ontologies based on a CSV file. That's something we do out of the box. So if I were to quickly show, if I bring in and I want to create a new ontology, for example, and I'll call this FinServe, Search the edge. So as Ralph was showing, I have the ability to actually index this entire ontology to make it available for search. But the moment I create a new ontology, it's going to ask me, hey, do you have anything? I can import this using a spreadsheet. So if you have a CSV file and you want to import it, great. If you already have something in RDF, whether it's Turtle, JSON LD, or RDF XML, you can also import that as well. Regarding scenarios, where are the contexts of your risk or the risk detected applying? They need to be modeled and structured as well or not? So the
that question's, I should look at the question perhaps, but well, can you repeat that, Norm? Yeah.
Yeah. So the question is regarding scenarios. Where are the contexts of your risk or the risk detecting applying? They need to be modeled or structured as well or not. And so I would say yes. The context is important, and we've already shown some of that context and be able to apply things like descriptions. But I would argue that that just becomes another piece of the knowledge graph, the context of the risk itself.
I agree with that, and it's possible to represent scenarios in a way that you could arrive at queries over all the knowledge graphs. That's possible, and it's interesting to think about and get feedback on that. What kind of examples of scenarios are interesting to show? Yes, in a second demo session we might do. Yeah.
There's another question here. Is there a way to visualize? We've seen a lot of connections between things. Is there a way to visualize? So the short answer is yes, we can. So I'll just jump quickly to this concept of the form. For some reason, this is taking a little bit longer. But this is the same data that Ralph was showing, the concept of I've got this risk analysis model. It's related to this particular risk. Edge has the ability to create diagrams. And so, for example, if I were to focus on the concept of the asset quality risk, what I can now do is say, I want to show, and again, these are all the relationships that we've created. So I want to do an analysis. I want to see who the compliance owner, I want to see the status of it, and I want to know what software is using and executing this particular piece. And so we have the ability to create these wonderful diagrams, all of them which I can move around. When I'm done, I can save these, I can print them, I can export them. But if I want to know more about the EBA risk, I can say, well, what's the broader? I'm not going to click the indicated. You can see there's 232 risk indicators that are related to this, but I can see there's a broader risk. And so I can start creating very big diagrams. So maybe I want to know more about the type of, this is a job title. This is going to be, oh, it depends on data from this thing. Oh, it uses an edge service. So I can create some very big diagrams when it comes to the relationships that we've created in the knowledge graph.
You might do an interesting one for market or the SME. The SME one is probably not so busy, yes, to show all the indicated buyers. Yeah.
True. Yeah.
But we've run out of time.
Yeah, I was going to say there's quite complex diagrams that you can create, but that's the concept of edge diagrams.
Well, thanks everybody for joining us. Thanks for all the questions. If we didn't get to your questions, we'll get to them after the session. As Norm mentioned, we will send out the slides and the recording. Thank you very much for your time.